Welcome back to the video series on integration and differential equations. Today we're going to be training your brain for differential equations. When we're solving differential equations, y is a function of x. For example, y might be something like e to the 2x or sine of 6x, etc. Occasionally we might use slightly different variables in the problem. Rather than using y and x, we might use y and t, for example, if we want to describe a problem in terms of time. Regardless of what we're calling our variables, there's one fact that's always true when solving differential equations, and that is that one variable depends on the other. So in any differential equation context, this will be true. Let's see what that means. If we wanted to integrate x squared with respect to x, we'd go ahead, use our usual power rule, and get x cubed over 3 plus a constant. If we wanted to integrate cos y with respect to y, then we would think back to our trig integration and we'd say the integral of cos y is going to be sine y plus a constant. But if we wanted to integrate something like xy dx, the issue here is that y depends on x, but we don't know at this point the exact formula for y, so we can't integrate this. We can't evaluate this integral because it is a mixture of x and y inside the integral. Similarly, if we wanted to integrate, say, cos x with respect to y, again the issue is we don't know at this point how y and x depend on one another. And so we can't evaluate the integral, again because we've got a mixture of x and y inside the integral. We're integrating with respect to y, but our integrand is in terms of x, so it can't evaluate. If you watched the previous videos on double integration, you'll notice that this discussion here is very different from double integration. So let's be clear that now that we're doing differential equations, we can only go through with an integration when we've got a single variable in the integral, and that includes the differential. So in each of these first two instances, we've got a single variable, whereas in each of the bottom instances, we've got a mixture of variables and we can't evaluate those integrals. Thanks for watching, and we'll see you in the next video.